Hello, guys. Welcome to today's episode of Ultrasound Knowledge. Today, we will be discussing how to maneuver to the gain. So, it's a very simple thing you can find in every machine. So, but we want to go into the effects and make you understand the effects that follows when you touch one parameter or the other. So there are some effects that we get to find if we adjust to the image parameters or to adjust the 2D gain, whether using the overall gain, the time gain compensation, or any other tool. So it's very important to mention that every machine, every ultrasound machine has ways of manipulating this particular control. So, and we are going to be looking into such manipulations and effects. Much of what we are going to do is to show you the effects of these manipulations. So, before we proceed, I want to encourage you all to subscribe to my YouTube channel, youtube.com/clinical imaging. Also, follow me on Facebook and Instagram, facebook.com/clinical imaging and instagram.com/clinical imaging. So without much further ado, let's get started. So gain settings in 2D mode ultrasound are usually done by two means. One is the use of the overall gain, and the other is with the use of time gain compensation or compensation, as many may call it. So these boxes contains similar name for the same thing. So whatever you see here means the same thing, and whatever you see here means the same thing. 2D gain, receiver gain, overall gain, amplification, they mean the same thing. Then on my right hand side, time gain compensation, depth gain compensation, compensation, they all mean the same thing. So I want you to get that cleared because we might be using them interchangeably. All right. So amplification, so the effect you get when you use the amplification button is that you have brightness changes on the entire image. All the beam of the ultrasound will have the same or similar brightness level. And because of this, is possible is very, very important to remember that the overall gain or the amplification cannot give you a uniform or a harmonized brightness. So compensation, which is also known as time gain compensation or depth gain compensation, this will give you a uniform brightness from the bottom of your screen down, from the top of your screen down to the bottom of your screen. It will give you similar brightness all over the beam of the ultrasound or all over your screen. So no matter the depth, whether you are the far field, whether you are the mid field, whether you are the near field, you get the same equal brightness. This is what makes it different from overall gain. So with overall gain, everywhere gets the same amount of brightness, but with depth gain compensation, you have similar gain regardless of the depth. So before us is an image of a 2D ultrasound beam. It was acquired with the highest overall gain compensation, overall gain, and optimal gain compensation. So here, amplification and TGC or DGC are optimal. But in this image, there is no internal organ or ultrasound acquisition of the internal organ demonstrated. So now, in this one, we now have an image of the liver demonstrated. We have to obtain this from a healthy volunteer. And as you can see, this image was acquired using the previous setting in the previous slide. So this setting was used to acquire this image of the liver. How do we know? It's the same setting. If you look at the decibel value, it's 20. If you look at the output value, it's 100%. If you look at the frequency, is 5. The same thing applies in the previous slide. So it's pretty much the same thing. But what is wrong? The only thing wrong here is that our amplification is at the highest level. And this is not good for image acquisition. So you need an optimal level. You need a good overall gain, which should not be at the highest level, and it should not be at the lowest level. So that is why the image before us is very bright. It's very, very bright, and it is not diagnostic. Now, this is a clip that shows us the effect that we will get when we adjust the overall gain. Look at the side, the right hand of the screen, and you will see that the overall gain is being incrementally adjusted from -20 to +20. So as we go from the -20, where you have less brightness, to 20, where you have the maximum brightness, you will see that the best image you can get is sit somewhere in between 0, -1, -2, -3, be between -5 to 5. So in between this range, you have to get find an optimal balance, which will give you the feel you need for your image. So for this one, we are increasing from the we are going from the under gain to the over gain. All right. So for the time gain compensation, this clip just shows you how the effects will look like when you touch or when you manipulate the depth gain compensation controls. So the depth gain compensation was adjusted from the near field to the mid field and then to the far field at the end. As you can see in this case, from the beginning to the end, there is changes at different levels or at different depths in the ultrasound beam. So we changed it from the top to bottom. And while doing this, our overall gain remained constant. We didn't change it. So the same thing here, overall gain is constant, and we are now changing and varying the levels of echogenicity or amplification or compensation at different depths using our depth gain compensation. So we adjusted it mid, near field, mid, and then far field is left untouched. So all these black areas are the areas that were manipulated, that were adjusted. The TGC knob was slide in the opposite way, whereas the areas that we see echoes, the TGC knob went in the opposite direction. The still image before you here is an image that we acquired using an improper depth gain compensation setting. So in this image, you can see that that the near field is undergained, the midfield is undergained, and in between it, we see an optimal gain of the liver parenchyma. Then here is also optimal. Then the far field is also undergained. Then if you look at our overall gain settings, you can see that we are now operating at a very good overall gain setting, which is -4 decibel. But the problem here, the only problem we have is that we have an improper depth gain compensation settings. So this is also a clip demonstrating the same thing in the still image. So showing us how the effect of depth gain compensation will look like if we maneuver it in this manner. Near field, nothing detectable, nothing diagnostic. Whereas in the midfield, we have something that we can say we are seeing, which is the liver parenchyma, and at the far field, there is nothing also. So this is a very optimal depth gain settings and a very optimal overall gain setting. There is no loss of reflection. All our image are uniform from top to bottom. There is no area of image loss aside the rib shadows, which is normal. So all our image is uniform. And this is how an optimal gain setting should look like. If you look at our overall gain setting, it is -4 decibel, which is optimal. Then our depth gain settings are also optimal, because if it is not, you might have a disproportionate echo reflections as you move down the depth of the screen. So let's move to the next. Um, the next is output versus overall gain. Output is not a way, is not a conventional way of changing the screen brightness or our image brightness. But it's worth mentioned because it is capable of changing the entire image brightness, and that is why I want to mention it. But it comes at a price. If you noticed, when we are changing our image brightness in for the depth gain compensation, our TIS, which is thermal index soft tissue, TIB, most importantly, our mechanical index does not change. It remains the same. If we check the previous slides, the same thing. If you check when we adjusted the overall gain, our mechanical index remained the same. It didn't change. So, but I'm going to show you the effect that changing our output power or output gain we have on our mechanical index. So, but before that, there are other names for transducer output or output gain. We can also be known as acoustic power, pulsar power, transmitter output, energy output. So the effect of this, like I've mentioned, and I want to stress on it again, is when you change it, every pulse transmitted to the body changes. So if the pulse transmitted to the body also changes, it is safe to say that the reflections we will get will also change, because the reflection are dependent on the kind of pulses we send into the body. So if the pulses are weak, we receive weak reflections. If the pulses are strong, we receive strong reflections. So attenuation happens no matter the kind of signal or the kind of pulse we send, but the weaker, the poorer the return. The poor signal we get will be much. But if we send a stronger signal, a stronger pulse, we receive a stronger signal. So it changes the entire image brightness. This works similar to overall gain, not like depth gain compensation. It works like overall gain. So let's see how it works. So this is an image. We have, this is the where you notice changes, if there is any, with your output gain or transducer output. So as you can see now, it is at 100%. You can see our mechanical index is 1.0. In this setting, our overall gain is also 20 decibel. That is, output is highest, 100%. Overall gain is also highest, 100%. So in this case, output is lowest. You can see 1.0%. Our overall gain is also lowest, minus 20 decibel. You can see the changes in between the two. Now in this one, we have output lowest, then we have overall gain highest. And that is why we have this very bright beam. Now in this one, output is 100%, is highest, but our overall gain is lowest. That's why everywhere looks dark, because our overall gain is at its lowest value. Now, output is 1%. Output is 1%, and our overall gain is minus 5, which is optimal. Remember, our optimal value when we didn't change our value for overall gain was 5, and we got a very good image, which has a uniform uh, background, and also a uniform top to bottom image appearance. This is it here. Okay, so we use minus 4 here, so minus 5 over there is not bad. So, and it gave us a very nice image. So but here we have minus 5. So but what is the problem here? It's very clear that overall gain is not the problem. This is the bad guy. Our output power or output gain is the problem. It is very, very low. It is at its lowest. So our overall gain is optimal. So, but what is the effect? What is the result? You can see that the image we have here is non-diagnostic. You can't really see anything on this image. This is an image of the liver. But you can see that because what you send in is what you get. That is why we are not able to send to get a very good image, or to get details from this image of the liver. If you look here at the far field, you can see that the far field, we can't actually see anything. We can only see the near field and some parts of the midfield. So this is what will happen when you reduce output gain to its lowest. All right. So this is a live adjustment of our output from 15% to 100%. You can see how the screen is changing from 15%. Now also notice the effect it has on our mechanical index. You can see that the mechanical index is going up. As it's going up, mechanical index is going up. When it was very low, mechanical index was low. Then when it was high at 100%, mechanical index is also high. So we are changing it, and you can see the effect it has on this on the beam. Everything is changing, and then it also affects our mechanical index. So you have to be very very cautious about this, because um, though there is no need for you to adjust to this, I just want to show you, for your curious mind, how the effect will look like if you should ever touch output gain. There are some rare cases whereby you may need this, probably in an obese patient or doing some other difficult studies, but rarely you don't ever touch this. Your output gain is usually a no-go area, except in extreme cases. Your overall gain and your depth gain compensation is enough or more than enough for you to maneuver or do any manipulations you want as regards the kind of contrast or kind of reflections you want to see, or the kind of brightness you want to see or have on your image. So now we are going from 100% to 10%. So you can see that the mechanical index is also going down with the output gain. As the output gain is going down, mechanical index is going down. And you can see the effect is here on the screen. The screen is changing. Is because we are changing this parameter here. We are changing this, but this is also going down with it. So both of them have a direct relationship. All right. So now we have a live image. So, and we want to know how that will look like when we have a live image on screen. Now we are decreasing our output gain from 15% to 2%. So when we are at 2%, you will agree with me that we have a better image than what we have right now. So as we go down, our image worsens. We lose detail from the far field. So, and it gets worse as we get closer to 1%. So, and also you notice that our mechanical index is also affected. It's going down with the output gain. If output gain is going up, it's also going up with it. So now, this is also a reverse of what we did in the previous slide. So we are moving from 1.3% to 10%. So as we are moving up, our image is getting better, and also our mechanical index is changing. So this is the effect you will get when you are moving from from the lowest point of the transducer output to a higher point. So you start to gain more detail from the far field. Your image becomes clearer. You get more details. So this is it. Uh, this is where we call it a wrap. And I thank you guys for, if you're watching this, I want to thank you for spending out the time to watch it. If you have any questions, you have to drop a comment so I can respond. And please also give me a follow on Facebook and on Instagram at Clinical Imaging. Also follow and subscribe on my YouTube channel, youtube.com/clinical imaging. So I'll be very, very happy to see you subscribe. So this is where we call it a wrap for today. And next time we have a very interesting topic. If you want me to discuss anything, just let me know in the comment section. All right. See you guys next time. Bye bye.